Welcome back to another episode of Second Career Pilot. Today we're getting right into the real core skills of flying by instruments.
Yeah, the basic maneuvers. We're leaning heavily on the FAA's Airplane Flying Handbook for this one.
Exactly. It's all about how you keep control when, you can't see outside. Super important stuff whether you're just starting IFR or just want to get chirper.
It really is. It's about trusting those gauges and knowing what they're telling you, how to maintain your flight path just using instruments.
Right. And not just maintain it, but change it. Deliberately climbs, descents, turns.
And crucially, how to recover if things get a bit unexpected.
Okay, so let's start with maybe the most fundamental thing. Straight and level flight on instruments.
The absolute bedrock.
The handbook points out something interesting right away, how pitch attitude changes with airspeed, even when you think you're level. Nose higher at slow speeds, lower at fast speeds.
That's a key concept.
Yeah.
Because your visual sense of level is gone. You rely entirely on the instruments.
So the attitude indicator is king here, for pitch at least.
It's your primary direct indication. Yeah. It shows you pitch and bank right now. But you can't just stare at it.
Mm-hmm.
You need the altimeter, the VSI, the airspeed indicator. They all give you that indirect feedback, confirming or sometimes correcting what you think you see on the attitude indicator.
And the handbook stresses really small corrections on the attitude indicator, right? Like
Yeah.
tiny movements relative to the horizon bar.
Oh, absolutely. Half a bar width, maybe a full bar width. We're talking finesse. No big yanks on the controls.
Smoothness.
Exactly. Smooth, small pressures. And, crucially, keep the aircraft trimmed. A well-trimmed plane almost flies itself in stable air. Relax that pressure once you're set.
Okay, let's talk about the altimeter then. How does that play into pitch control?
Well, it's indirect, like we said. If your power is constant and the altimeter starts creeping up,
Your nose is too high.
bingo. So you need a slight nose-down correction. And it's not just that it's climbing, but how fast it's climbing. A fast-moving needle means a bigger pitch deviation.
So you correct to stop the trend, then correct again to get back to the altitude.
Precisely. Don't chase the needle. Make a definite correction. Check the result, then adjust again if needed.
Got it. And the VSI. It shows trend and rate, but it lags a bit.
Yeah, that lag is important. You don't want to rely on it for your initial pitch correction because it takes a second or two to catch up.
Okay.
But it's great for seeing if you started a climb or descent and then it settles down to show you the actual rate. Very useful for establishing, say, a 500 foot per minute descent.
And there's a rule of thumb for corrections, something about doubling the error.
Yeah. If you're, say, 100 feet off altitude, the common technique is to initially establish a rate of return of about double that, so 200 feet per minute, back towards your target altitude, then smoothly level off.
Okay, makes sense. What about the airspeed indicator's role in pitch?
Again, indirect, assuming constant power. If your airspeed starts dropping,
Nose has probably come up.
right, and if airspeed is increasing,
Nose has probably dipped down.
exactly, it all ties together. Constant power plus constant pitch attitude generally equals constant airspeed in level flight. They're all linked.
So pitch covered. What about keeping the wings level? Bank control.
Attitude indicator is primary again for bank. Direct picture of your wings relative to the horizon.
Uh-huh.
But you're constantly cross-checking with the heading indicator. Is the heading staying put? If not, you've got a slight bank you need to correct.
And the turn coordinator. That little airplane or the ball.
Yeah, the turn coordinator mainly shows the rate of turn and, crucially, a quality of the turn that's the ball. Keep the ball centered with rudder for coordinated flight. You want to avoid slipping or skidding.
Right. Even tiny banks add up over time and drift you off course.
For sure. So keep scanning attitude, heading, turn coordinator. And power, of course. Power affects altitude and airspeed.
You can trade one for the other, right? Altitude for airspeed or vice versa.
That's a fundamental concept. Reduce power slightly and hold altitude. Airspeed decreases. Lower the nose slightly with the same power. Airspeed increases, altitude decreases. You manage energy.
The handbook has that example of slowing down in level flight, say from 120 to 100 knots.
Yeah, that's a good one because it shows how the primary instruments shift.
How so?
Well, as you reduce power to slow down, you'll need to raise the pitch slightly to maintain altitude. So the altimeter becomes your primary pitch instrument temporarily. You're adjusting pitch to keep the altimeter steady.
Oh, okay.
Your heading indicator is still primary for bank, keeping you straight. And the airspeed indicator becomes primary for power. You just power to nail that target 100 knots.
It's like a constant scan and reprioritizing based on what you're trying to achieve.
Exactly. Scan, interpret, control, trim. That's the loop.
And the common mistakes here. Over-controlling, maybe. Not trimming.
Definitely. Chasing the attitude indicator,
Mm.
making abrupt power changes, forgetting to trim out the pressures, and letting the heading drift off because you're fixated on pitch or airspeed. It takes practice.
Okay, let's talk climbs and descents. Entering a climb, say, constant airspeed climb.
Right. From cruise, you'll simultaneously increase pitch to your target climb attitude using the attitude indicator and apply climb power.
Uh-huh.
As the airspeed settles onto your target climb speed, say V or maybe an en route climb speed, the airspeed indicator then becomes your primary reference for pitch. You adjust pitch to hold that airspeed steady.
And for a constant rate climb, like 500 feet per minute.
Then the VSI becomes your primary pitch reference, supported by the attitude indicator. You're adjusting pitch to hold that desired rate on the VSI while still monitoring airspeed. You might need small power adjustments too.
Leveling off seems like a place you could overshoot easily.
It is. You need to lead it. Start lowering the nose before you reach the target altitude. A common rule of thumb is to lead by about 10% of your vertical speed.
So if climbing at 500 feet per minute, start leveling off 50 feet below.
Something like that, yeah. It requires anticipating and smooth control inputs, then adjust power back to cruise setting as you accelerate.
In descents. Pretty much the reverse.
Basically, yes. For a constant airspeed descent, you reduce power, lower the pitch using the attitude indicator initially, and then use the ASI as primary for pitch to hold your descent speed.
Leveling off requires a lead again.
Definitely. Especially if leveling off at a higher airspeed than your descent speed. You'll need to start adding power before reaching the altitude to arrest the descent and allow the aircraft to accelerate in level flight.
What are the common pitfalls in climbs and descents?
Probably chasing the VSI or ASI with jerky pitch movements, not setting the power correctly or forgetting to adjust it, and again, poor trimming habits.
Makes sense. Let's turn to turns. Standard rate turns first.
Okay, standard rate is 3 degrees per second. That's a full circle in 2 minutes. Handy reference.
And the bank angle needed depends on airspeed, about 15% of true airspeed.
That's a good ballpark figure, yeah. So faster you go, the steeper the bank needed for a standard rate turn.
How do you initiate it?
Roll in smoothly, using the attitude indicator to establish that approximate bank angle. Then, your primary bank reference becomes the turn coordinator. Adjust the bank slightly to keep that needle or miniature airplane right on the standard rate mark.
And you need to watch pitch and power too, right? Might need a little back pressure.
Often, yes. Especially in steeper turns, the vertical component of lift decreases, so you'll need a slight increase in pitch attitude, maybe just a touch of back pressure to maintain altitude. Sometimes a tiny bit of power too.
Recovering is just coordinated rollout.
Yep. Coordinated aileron and rudder using the attitude indicator and heading indicator to roll out smoothly onto your desired heading. You'll need to lead the rollout, just like you lead the level off.
Lead depends on the bank angle.
And rate of turn, yes. Steeper banks require more lead. Half the bank angle is a common starting point for the lead.
What about timed turns, using the clock?
Yeah, if your turn coordinator is accurately calibrated, you can time your turn. Start the clock as you establish the standard rate bank, turn for the required number of seconds, and roll out. Good backup technique.
Compass turns sound tricky. Magnetic dip and all that.
They are. The compass lags when turning through north and leads when turning through south,
Yeah.
in the northern hemisphere anyway.
Yep.
And there are deceleration errors too. You need specific techniques for turning to cardinal headings accurately using just the magnetic compass. It takes practice.
Steep turns more than standard rate. Sounds like workload goes way up.
It does. Much faster cross-check needed. Pitch control is critical because the tendency to lose altitude increases. And overbanking is a real risk.
Leading to that diving spiral.
Potentially, yes. That's where the bank increases, the nose drops, the airspeed builds rapidly. It's an unstable situation you need to recognize and correct immediately. Reduce power, level the wings, then gently raise the nose.
Okay. Climbing and descending turns are just combining the skills.
Pretty much. You establish the climb or descent, then roll into the turn, managing pitch, bank, and power throughout.
What about changing airspeed during a turn, like slowing down while turning?
You can do it. You reduce power, adjust pitch to maintain altitude, and here's the key you'll likely need to decrease your bank angle to maintain a standard rate turn as your airspeed drops. Then coordinate the rollout. Common errors in turns involve poor rudder coordination, fixating on one instrument, or not adjusting pitch and power correctly.
Got it. We should touch on practicing approaches to stalls under the hood.
Right. Important training maneuver. You slow the aircraft in different configurations, clean, take off, landing, feel the cues, recognize the impending stall, and recover promptly.
Recovery being key. Reduce angle of attack, add power smoothly.
Exactly. Break this all first.
Now, unusual attitudes, hopefully rare, but possible.
Very rare in normal instrument flight if you're flying correctly, but could happen due to disorientation, turbulence, instrument failure maybe. You recognize it by seeing crazy readings on the attitude indicator, altimeter unwinding, VSI pegged, airspeed changing rapidly.
First step.
Recognize and confirm. Increase your scan speed. Is this real? Okay, it is. Then correct.
Nose high recovery.
Power up, full power usually. Forward elevator pressure smoothly but firmly. Lower the nose towards the horizon. Level the wings using coordinated controls.
And nose low.
Power back, reduce power to prevent overspeeding. Level the wings first coordinated roll. Then smoothly raise the nose back to the horizon.
Avoid chasing it after the initial correction.
Crucial. Make the correction, then immediately check the results on the instruments.
Yeah.
Avoid over-controlling into a secondary unusual attitude.
Yeah.
And trim, trim, trim once you're stable.
Lastly, the instrument takeoff. Seems like high workload right from the start.
It is. Preparation is key. Align perfectly on the center line. Set the heading indicator precisely. Smooth power application.
Using rudder for directional control.
Primarily rudder, yeah. Keep it straight down the runway. As you approach rotation speed, smoothly establish the takeoff pitch attitude on the attitude indicator, usually around a 2-bar with climb indication.
Don't look outside.
Transition to instruments before liftoff or right at liftoff. Attitude indicator for pitch and bank. Heading indicator to confirm you're tracking the extended center line. Positive rate of climb confirmed on VSI and altimeter, then gear up.
Flaps up at a safe altitude, too.
Right. Follow the aircraft procedures, maintain that clawing attitude, get trimmed. Common errors are rushing, poor alignment, jerky rudder control, or rotating too early or too late based on instrument indications.
Wow, okay. That covers the core maneuvers. It really hammers home how interconnected everything is: pitch, bank, power, trim, and that constant instrument scan.
It really is the foundation. Mastering these basic straight and level climbs, descents, turns, recoveries builds the skill and the confidence you need for actual IFR flying, like shooting approaches. It's all about that precise control by reference to instruments.
Understanding how each instrument contributes, knowing which one is primary for what you're doing at that moment.
And developing that smooth, coordinated touch on the controls. That's what separates proficient instrument pilots.
Absolutely. And always, always check your specific aircraft's manual, the POH or AFM, for the exact perceivers and speeds.
Couldn't agree more. The handbook gives principles, the POH gives specifics for your airplane.
Well, this has been a great breakdown of the fundamentals, essential stuff for any pilot flying instruments. Thanks for listening.